goal of this video is to be able to rearrange equations more efficiently and be able to rearrange and solve more complex equations. That's equations with the unknown on both sides of the equation, or when there's more than one unknown in the equation, so you can't get an exact numerical value. So let's start with these equations here. Now I'm going to solve the equations below the line and leave the ones up above untouched so that we can compare before and after. So if we start with this first one, we've got x plus y equals z. Now the opposite of adding y is subtracting y. Now one thing to note is that because we don't know what z or y are, we can't actually subtract them, and we're just going to have to say that x is equal to z minus y. So even though we don't know what z or y are, we can still write that we want to subtract y from z. Alright, let's do the next one. The opposite of subtracting y is adding y. It's going to add y to both sides. It's going to cancel out. And we're going to be left with x is equal to z plus y. The next one, we have x multiplied by y. So we're going to divide both sides by y to cancel it out. And we're going to end up with x equals z over y. And lastly, we have x divided by y, so we're going to multiply both sides by y, and we're going to end up with x equals zy. Okay, so what we want to see is that from where we started up on the top for each of these equations to where we ended on the bottom of these equations, what has happened. So for each one of these equations, the only thing that has happened is the y has moved to the other side of the equation. In the first equation, it was an x plus y on the left side, but on the right side, it is now saying z minus y. Now we can see why that happened, because we subtracted y from both sides, which got rid of the y on the left side and then appeared on the right side as a minus y. So what ends up happening is whenever you're solving an equation, the thing that you want to get rid of will appear on the other side of the equation, but always doing the inverse of what it was doing where it started. So let's have a go at solving this equation by doing what I was just talking about. We're going to take each part of the equation and we're just going to move it to the other side and make sure it does the opposite when it gets there. So we'll have the thing at the top as a reference for what we started as, and then down the bottom I'm just going to move some things around. So just like normal, we want to get rid of the minus 7 first, so I'm going to move the minus 7 to the other side of the equation. However, it now needs to be a plus. If it was a minus on the left side, it needs to be a plus on the right side. Now I've got to divide by 3 on the left side, so I'm going to move that to the right side, except now it needs to be multiplying by 3. I'm going to move the plus 3 to the other side, but now it needs to be a minus 3. And then I'm going to move the 4 to the other side, but it needs to be dividing by 4. Same rules apply where you need to do things in reverse order of operations, and you need to make sure you're doing things to the entire side. But that is what you end up with by rearranging the original equation. Now, at any point here, I could have calculated these as we go. So like 2 plus 7 is 9, multiplied by 3 is 27, subtracting 3 is 24, divided by 4 is 6. So we get our answer of x equaling 6, but all we were doing was just moving things to the other side of the equation, making sure that they're doing the inverse when they get there. Okay, now that we know how to rearrange equations more effectively, let's have a look at this equation here. I'm going to say 16 divided by x equals 2. That's a pretty simple equation, and some of you might be able to guess what the answer to this is. If we wanted to do 16 divided by some number equals 2, that number would have to be 8. So the answer we're looking for is going to be 8, but let's see how we're going to get there. If we could just do the same thing we were doing before, we can move the x to the other side of the equation, because the main issue we have at the moment is that x is on the denominator of that fraction. When x is on the denominator of a fraction, it makes it very hard to solve for, so we need to get it off the denominator as quickly as possible. So let's take this x, and if we wanted to do it properly, we could say that we're going to multiply both sides by x so that the x's would cancel. Or alternatively, we can just go, look, I know that I can move this x to the other side. The x was dividing on the left, so when it goes to the right side, it should be multiplying. And then I can say that 16 equals 2x. Now, if 16 equals 2x, now I can do my regular solving. I divide both sides by 2, which is, of course, going to move that 2 to the other side. So when it gets to the other side, it's going to be dividing. Now, x equals 16 divided by 2, which means x equals 8. Let's do another one quickly. Let's say I had 20 divided by x equals 5. What I can do is I can take this x, I can move it to the other side. Now it is 5 times x. I want to move the 5 away from the x, so let's do that. When it gets to the other side, it needs to be dividing. I have x equals 20 divided by 5, which equals 4. So we can rearrange these equations very easily, just move things to the other side as you see fit. Make sure that they are doing the opposite when they get there. One of the biggest mistakes people will do is they'll say have something like 5x equals 20, and then they'll say that x equals 20 minus 5. However, this 5 is multiplying the x, so it should be dividing when it's on the other side. Be very careful that you're choosing the right operation when it arrives there. If you're ever unsure, then go back to the usual method of divide both sides by 5, multiplying and dividing cancels out, so x equals 4. Both ways work, one way is just slightly quicker. The last kind of equation that we're going to cover is what happens if we have x's on both sides of the equation. So again, our end goal is to have x equals something when we're done. In order for that to happen, x needs to be on the numerator, can't be on the denominator of a fraction, but also we can't have x's on both sides of the equation. So what we can do is we can just move some things away from x like we normally would. I'm going to put the minus 7 on this side, make it a plus. And then this here, this is a positive 4x. I'm going to move it to the other side, make it a negative 4x. Now the 6x and the 4x can combine together because they are like terms. So 6x minus 4x is 2x, 13 plus 7 is 20, and now we can solve for x by moving the 2 to the other side, except with division, so x must equal 10. So whenever you have x on both sides of the equation, you need to merge them together. The final thing that I'll just mention is that none of these techniques quite work if you have different kinds of x. So if I had x squared plus x equals 7, you need a completely different set of techniques to try to solve that kind of equation. So this only works if you've got one kind of x, where you can merge them all into one x term, and then you can solve for it by moving everything else away.